In this video, I'm going to look at question 6. So it says this is 6.1 in the diagram, point P with coordinates of -5 and 12, and T lies on the positive x-axis, and angle POT is equal to theta, and then we are given a diagram. So the first thing that we need to do is to evaluate the diagram, and then from there answer the questions following the diagram. Okay, so we have here point P, so I'm just going to highlight this information here. So we have point P here, and with the coordinates of -5, and then we have that angle POT is equal to theta. So now the first thing that we want to do is to look at point P. So this point here with the coordinates of -5 and 12, because we know that when you write the coordinates, it's always when you write the coordinates is always x and y. So we have here, if you write the coordinate, it will be x and then y after. So meaning that in this case, -5 is x coordinate and then 12 is y coordinate. So I'm just going to complete this as this to form a right angle triangle. So this side will be our x. So in this, x will be -5, and then our y will be 12. And then so we need to find the value of hypotenuse. So we have the opposite and then we have the adjacent. Okay, so using Pythagoras, r will be the root of x squared plus y squared, and x is -5, then we square it, and then we also have y to be to +12, and we square it. Then this will give you 25 plus 144, so that will give you the root of 169. So the reason here we don't have plus or minus, because the reason is that hypotenuse will always be positive. It will never be negative. Only x and y, or opposite and adjacent, can be positive or can be negative, but hypotenuse will always be positive. So in this case, square root of 169 will be 13. So the value of r is 13. All right, so with this, now we're gonna answer the question. So we look at 6.1.1. So 6.1.1, write down the value of tan theta. So tan theta without using a calculator. So tan theta, when you use the diagram, tan is opposite over adjacent, so is 12 over -5. So that will be the answer for tan theta. That is 6.1.1. And then 6.1.2, calculate the value of cos theta. So cos theta, cos is adjacent over hypotenuse. So adjacent is -5, and then hypotenuse is 13. So that will be the answer, -5 over 13. And then lastly, so in 6.1.3, S with the coordinates A and B is a point in the third quadrant such that angle TOS is equal to theta plus 90 degrees, and OS with a length of 6.5 units. Calculate the value of B. So I'm just going to draw the diagram that represents 6.1.3. Okay, so 6.1.3, if you draw the diagram, this will be the diagram. So I'm just going to draw a rough sketch of that. So we have here is in a third quadrant. So S is in the third quadrant, or that will be somewhere here. It doesn't have to be accurate as long as it's in a third quadrant. So if this is the S with coordinates of A and B, where A is the X coordinate and then B is the Y coordinate. So if you complete this, it will be like this. If you use a triangle, your X value is A and then your Y value is B. Okay, based on the coordinates of S. And then we know that from the given information that angle, this line, the origin is O. So the origin is O, of course, with the coordinates of 0, 0. So in this case, they said the length of OS is 6.5. So this is 6.5. That is our hypotenuse. So the question here is to calculate the value of B if angle TOS is theta. So from the previous statement, it was given that T, or from the previous diagram, T was on the positive side of x-axis. So if this is T, the line, the angle between T and OS, or the angle TOS, this is the angle here, is theta plus 90 degrees. So that angle is theta plus 90 degrees. So the question here is to find the value of B. So B is our Y, which is our opposite angle. So if you say, if you answer that question, you will gonna say sine of theta plus 90 degrees will be opposite over hypotenuse, which is B over 6.5. B over 6.5. But sine theta plus 90, okay, you can write it as 90 degrees plus theta. Okay, so on the other side is still the same, B over 6.5, the right hand side. So when you write it this way, if you look at this part here, it looks familiar. This, we know that if you use the, you can also check that I already highlighted that in the previous videos. So when you use reductions formulas, you will see that this will become cos, positive cos theta. So this will change to be positive cos theta because that is in so but the point here is that this is in a this is in a, if you use these formulas here, this is 90 minus theta and then 90 plus theta. So if you use that, you will see that it will give you negative cos. So sine is positive in the second quadrant. However, cos is negative. All right. So this is cos theta, which is B over 6.5. But now, using the previous answer, 6.1.2, we said cos theta is negative 5 over 13. So the reason why we substitute negative 5 over 13 on the left hand side is because the ratio is the same, because both are cos and cos. So because we call this trigonometric ratios, you know that if you say 1:3 is the same as saying 15 is to 45. Or you can also say that 1 is to 3 is the same as saying 25 is to 75. These ratios are the same. So ratio and fractions, we treat them the same. So in this case, because cos theta from the previous answer is -5/13, it will be the same if the angles are the same. So both of these questions are with theta, so it has to be the same. The ratio will be the same. So this will be equal to b over 6.5. So if you cross multiply, b will be -5 multiplied by 6.5 over 13. So that is when you cross multiply, you will get the answer for b, which will be -5 multiplied by 6.5 divide by 13. That gives you -5/2. Or if you write it as a fraction, that would be -2.5. So you can keep it as a fraction or you can keep it as a decimal. So that would be the answer for 6.1.3.